Page 42, Section 2, Heat Transfer. You pour a cup of steaming tea from a teapot. Your teacup is warm to the touch. Somehow, heat was transferred from one object, the cup, to another, your hand. That it was touching. This is an example of conduction, one of three ways that heat can be transferred. As you'll learn in this section, heat transfer in the troposphere plays an important role in influencing Earth's weather. Thermal energy and temperature. The tea in the cup and in the teapot are at the same temperature, but have a different amount of total energy. To understand this, you need to know that all substances are made up of tiny particles that are constantly moving. The faster the particles are moving, the more energy they have. Figure 4 shows how the motion of the particles is related to the amount of energy they hold. Temperature is the average amount of energy of motion of each particle of a substance. That is, temperature is a measure of how hot or cold a substance is. In contrast, the total energy of motion in the particles of a substance is called thermal energy. The hot tea in the teapot has more thermal energy than the hot tea in the cup because it has more particles. Measuring temperature. Temperature is one of the most important factors affecting the weather. Air temperature is usually measured with a thermometer. A thermometer is a thin glass tube with a bulb on one end that contains a liquid, usually mercury or a colored alcohol. Thermometers work because liquids expand and when they are heated and contract when they are cooled. When the air temperature increases, the temperature of the liquid in the bulb also increases. This causes the liquid to expand and rise up the column. Temperature scales. Temperature is measured in units called degrees. Two temperature scales are most commonly used, the Celsius and the Fahrenheit scale. Scientists use the Celsius scale. On the Celsius scale, the freezing point of pure water is 0 degrees, read 0 degrees Celsius. The boiling point of pure water at sea level is 100 degrees Celsius. Weather reports in the United States use the Fahrenheit scale. On the Fahrenheit scale, the freezing point of water is 30 degrees Fahrenheit and the boiling is 212 degrees Fahrenheit. How is heat transferred? Heat is the transfer of thermal energy from a hotter object to a cooler one. Heat is transferred in three ways: radiation, conduction, and convection. Radiation. Have you ever felt the warmth of the sun rays on your face? You are feeling energy coming directly from the sun as radiation. Recall that radiation is the direct transfer of energy by electromagnetic waves. Most of the heat you feel from the sun travels to you as infrared radiation. You cannot see infrared radiation, but you can feel it as heat. Conduction. Have you ever walked barefoot on hot sand? Your feet felt hot because heat moved directly from the sand into your feet. The direct transfer of heat from one substance to another substance that is touching is called conduction. When a fast-moving sand molecule bumps into a slower-moving molecule, the faster molecule transfers some of its energy. The closer together the atoms or molecules in a substance are, the more effectively they can conduct heat. Conduction works well in some solids, such as metals, but not as well in liquids and gases. Air and water do not conduct heat very well. Convection. In fluids, liquids and gases, particles can move easily from one place to another. As the particles move, their energy goes along with them. The transfer of heat by the movement of fluids is called convection. Heating the troposphere. Radiation, conduction, and convection work together to heat the troposphere. During the day, the sun's radiation heats Earth's surface. The land becomes warmer than the air. Air near Earth's surface is warmed by both radiation and conduction. However, heat is not easily transferred from one air particle to another by conduction. Only the first few meters of the troposphere are heated by conduction. Thus, the air close to the ground is usually warmer than the air a few meters up. Within the troposphere, heat is transferred mostly by convection. When the air near the ground is heated, its particles move more rapidly. As a result, they bump into each other and move farther apart. The air becomes less dense. Cooler, denser air sinks towards the surface, forcing the warmer air to rise. The upward movement of warm air and the downward movement of cool air form convection currents. Convection currents move heat throughout the troposphere.